Alright, so now let's take a look at a very useful technique in which we will find the rational approximation of irrational numbers. Okay, so let's take a very simple example to begin with. I take the value of pi as 3.14159 and then it goes on forever. Okay, and my approximation target is that I want to find a decimal number which is up to 2 decimal digits expanded. Okay, so what you really do is you take a look at this third decimal digit, that is right after the second decimal digit, right? It is 1. And then compare that value, whatever that value is, if that digit is greater than or equal to 5, then you simply increment the value of the second decimal digit by 1. If it is less than 5, then you just let the second decimal digit be as it is and ignore the rest. So in this case, I see that the third decimal digit is 1, which is very clearly less than 5. So I will just simply ignore all of these numbers and my approximation will be just 3.14. Okay, now let's take the same number all over again. I take that pi is equal to 3.14159 and then so on. In this case, my approximation target is only up to the first decimal digit. Right? Then I take a look at my second decimal digit, right? Because I want to approximate only up to the first decimal digit. Hence, my next number for comparison would be the second decimal digit. I see that 4, it is less than 5, right? So I can simply choose to ignore all of them and my approximation will be equal to 3.1. Okay. Now that was example 1. Let's take a look at a little bit complicated example. We have another irrational number, square root of 5. I want to find the rational approximation to it. Okay. Now, the first step what I'll do is I'll find out two perfect squares that this number 5 will fall in between. So that is 4 and 9. Square root of 4 and square root of 9. These are the two boundaries that this square root of 5 will fall in between. Now, what is square root of 4? It is 2. What is square root of 9? It is 3. That means if I simply draw a number line that is between 2 and 3, or that is between square root of 4 and square root of 9, then you will see that I can divide this number line in 5 equal parts, because between 4 and 9 there are 5 steps. So that will be 5, 6, 7, 8, and of course you are here at 9, right? Or you can just simply put a square root for each one of those steps. So this is a very clear division of this number line, starting from square root of 4, going all the way up to square root of 9, and each part is equal to 0.2. Hence it will be 2.2, and this is going to be 2.4, and this is going to be 2.6. This is 2.8, and of course you are here at 3.0. And that is what? That simply means that the square root of 5 is right here at this point, correct? And hence that is exactly what my answer. The square root of 5 with 1 decimal digit accuracy is 2.2. Simple enough, right? Let's take one more quick example. In this case, I want to find the square root of 13. Okay. Can we find two perfect squares such that the number 13 will fall in between, right? So that will be between 9 and 16. You follow me, right? So between 9 and 16 is the number 13. And the reason I chose 9 is because when you take a square root of 9, you get 3. When you take square root of 16, you get 4. And I was looking for perfect squares, right? Now, the next step, I will simply draw a number line that is between 3 and 4. Or in other words, it is square root of 9 and square root of 16. Now, how many steps are there in between 9 and 16? There will be 7 steps. So let me put those here. 1, 2, 3, 4, 5. No, that's not the correct one. So let me do it again. So that will be 1, 2, 3, 4, 5, 6. And of course, you have your 7. So that means between 9 and 16, this will be square root of 10, square root of 11, square root of 12. This is 13. 14 and square root of 15, and then you of course are here at 16. So you have clearly divided the space between 3 and 4 in 7 equal parts, where each part is equal to 1/7, or it is equal to, let's say, 0.15. Right, now you see the square root of 13, it is how many steps away from 3? It is 1, 2, 3, 4. That's exactly where my square root of 13 is. So that means the square root of 13, which is 4 steps away from the left hand side, is going to be 0.15, it is 0.3, then you have 0.45, and then you will have 0.6. So the square root of 13 is going to be equal to 3.6. Okay. So you see that this is my rational approximation of this irrational number, that was 13. So square root of 13 is going to be equal to 3.6. So we learned two different techniques. The technique one is, if you are already given a decimal number, how do you truncate it down to your required decimal number and make it like a rational number. And the second technique was by the example of square root of 5 and square root of 13 was, how do you find a quick approximation of those square roots without the use of calculator, using the concept of number line.